Hey everybody, happy Thursday. Mr. Marquardt again with you. We are finishing up chapter 2 today, the last section of that wonderful chapter talking about slope and lines and a whole bunch of good stuff. So we're going to kind of tie a bow on all of it today and find the equations of a line through 2 points, kind of the last piece of the puzzle for all this. A couple of announcements. Homework collection number 10 is posted tomorrow, so make sure you go on and take a look at that and post that homework whenever you get a chance to. We're going to finish the toolkit today. If you want to check the homework, check the filled-in notes on its learning after this, and same thing for the toolkit. Check the filled-in notes for both of those. Otherwise, we're just going to jump straight into the lesson for 232. So here we go. Again, finish your toolkit, check the notes on its learning. Otherwise, it's going to take too long to do that here. So here we go. 232, what is the equation of that line? Finding the equation through 2 points. So yesterday we figured out how to find the equation of a line when we're given 1 point and the slope. Today we're going to work when we're given 2 points and practice using that point slope formula, which again, hopefully we remember what this one is. It's where we have our slope is equal to y2 minus y1 over x2 minus x1 when we are given 2 separate coordinate points on a grid or on a line here. So that would mean like we would have at least 2 coordinates, both that are x, y, something like this, where we could label one as like coordinate number 1, coordinate number 2, where then those subscripts become x1, y1, x2, y2, and then we can plug in those variables to their respective spots in that point slope equation right there. So we're going to practice using that today and using that to find equations of lines in a little practice problems here. So here we go. So 289, in this problem we want to find the equation of a line that goes to the points listed in our table below. So we're going to use the questions to help organize our work. So first things first, what's the slope of this line? So I'm just going to pick 2 random points on this table. I'm going to pick this one, 1452, that's going to be our point number 1. And I'm going to pick 1864 as our second point. So again, if we put those as a coordinate point, we would have, again, number 1 is 1452. And our second one is 1864. And again, we want to keep in mind that our coordinate pairs always go x, comma, y. So we know where to plug in those values when we're trying to find the slope. So again, our point slope formula is m equals y2 minus y1 all over x2 minus x1. So from here, we just got to plug in the right values. So this is coordinate number 1 on the left, coordinate number 2 on the right there. So we have to put in our coordinates on the right first. So for m, we know it's going to be something minus something else. So here we go. Our y2 is 64 because it's the y value of our second coordinate. From there, we are subtracting y1, which is the y value of our first coordinate, which in this case is 52. On the bottom is our x2, which is 18. And then we're subtracting our x1, which is the x coordinate from coordinate number 1. So in this case, it's 14. So if we subtract 52 from 64, we are left with 12 on top. On the bottom, 18 minus 14 is 4. So now if we want to simplify that fraction, we take 12 divided by 4, should get us a nice round 3 there. So 3 would be our slope for this line. So does it matter which points we use in order to find our slope? So let's practice here. Let's pick 2 different points and see if it changes. So for example, let's say our new point number 1 would be negative 27, negative 71, and our new number 2 is going to be 2997. So I'm going to slide this down just a little bit. But again, remember our point slope formula, which is right here. That's what we need to use when we're given 2 points to figure out what that slope is going to be. So now let's label our new points and move on down here in green. So number 1, our new number 1 was minus 27. And then we had minus 71. Then over here we had our second one, which was in red over here is 29, 97. So now we got to plug in our numbers into the point slope formula. Again, knowing that this is our number 2 coordinate, number 1. So we have x2, y2, x1, y1. And now let's plug those in. So y2 minus y1, so we have 97 minus a minus 71 all over. Now we have our x2, which is 29. We are subtracting a negative 27. So if we think back to our algebra tiles, hopefully we all remember that when we subtract a negative, those values flip, so that turns into a addition problem. So here we have 97 plus 71, and we have 29 plus 7 or 27 on the bottom. So what that turns into is 168 all over 56, which if you put it in your calculator, just like that, 168 divided by 56, we would get that to equal 3. So we get the exact same slope no matter which points that we pick. So it doesn't matter? Absolutely not. It does not matter which points we pick as long as we are consistent in labeling our x1 or y1, x2, or x2, y2, and we plug those into the right spot in our formula. It does not matter. What point we use. So how can we use a point to find the equation? Again, that's what we did yesterday in class. We have one point we can use and we know our slope now, so we can plug that in to our point, or our y equals mx plus b, which is the general equation of our line. Again, we can just pick any random point off of our table. So let's go back and let's use 1452. 1452, again, we know that our slope is equal to 3. So now, again, this is x, this is y. Let's plug those numbers into our equation and then solve for our intercept. So now we know that 52 is equal to 3 times 14 plus our b value, which we do not know yet. So 3 times 14, I believe, is 42. So we're going to draw arrows going to the right here. So 52 is equal to 42 plus our b. So now we got to subtract 42. Subtract 42. Cancel on the right. So we are left with a positive 10 on the right or left-hand side, and on the right-hand side is our intercept, so we know that our intercept is equal to a positive 10. So when we plug that back into our equation, we need to know our slope, we need to know our intercept, so we can finally say, using both of those pieces of information, that our equation for that line is y equals 3x plus 10. All right. So then, once we have our slope, does it matter which point we use to find our equation? Absolutely not, because we know that all of those points are still on that line and are part of that table, and like we proved before, we can get the same slope using any 2 points, so we can use any point in that table to find that equation. It's really a matter of personal preference which one you want the most. And then how can we verify our equation is correct? Let's plug a value in for x and see what we get. So if we, again, let's use the same point. We want to test that if we plug in 14 for x, that we get 52 back. So we're trying to see if we get 52 back. And our equation now is y equals 3x plus 10, like we found just a second ago. Plug in 14 for x, so we get y is equal to 3 times 14 plus 10. So we get y is equal to 42 plus 10. So our y is 52, which is good because that's exactly what we had for our coordinate pair, what's in our table, so we know we did our job right. So let's move on to 88. So this is what we're really trying to focus on today. We're hammering home how to find slope with 2 points and how to find the equation of a line given 2 points and then trying to find our intercept like we did yesterday with being able to just plug that into an equation with a point in our slope and find the intercept and find the equation of our line in general. So we're going to do design A together. You can do design B on your own for some more practice, but just for the video, we are just going to do design A. So the Line Factory needs a logo for its pamphlet, and after much work, the logos below were proposed. So the design department knows the coordinates of special points in each logo. However, programmers need to have the equations of the lines in their program so the pamphlet software can actually make that logo. So we want to explore using the Desmos tool. We're not going to do that because we have it on the bottom right here. But we're going to use this design to try to figure out what the equation of all four of those lines are so we can plug that back into the software for our designers here. So I'm going to label our lines as line 1, I think we'll call this one line 2, line 3, and then line 4. So we want to find all four of those equations. All four of those equations. And then we're going to try to find their domain and range as well. So if we go to the next page, we can work on that. If you guys want to keep track on the back of your next page here, but otherwise I'm going to do my work underneath. So let's start with line 1. First things first, let's go back up to our picture and try to figure out where those 2 points are and what the coordinates are. So we have this point and this point on line 1. So I'm going to write those down here for line 1. So our number 1 point, or the first point that we see is 35, 168. Our second point is 57, and then 278. So if we want to find the slope, again, point slope formula, just like we talked about, y2 minus y1 over x2 minus x1. So if we plug that in, I'm going to write that on the side here just for reference. M is y2 minus y1 over x2 minus x1. All right, so let's plug our numbers in. So again, xy is always our coordinate pair, xy is always our coordinate pair, so we got to plug in the numbers according to our coordinate. Again, we got number 1 and number 2. So our y2 for this line is 278. We're subtracting our y1, which is 168, all over our x2 is 57. Our x1 is 35. So when we evaluate that, we should get 110 over 22, which we can simplify one step further, which would be 5 over 1, or our slope is going to be equal to 5. All right, so now we know that our slope is 5. Let's try to figure out what our y-intercept is going to be. Again, we know our equation for a line is y equal mx plus b. So we have 2 points. Let's just pick a random point to plug into that equation along with our slope to find our intercept. So let's use our point number 1, which is going to be 35, 168. So again, our y is 168. So we have to say 168 is equal to, our slope is 5, our x is 35. We are trying to figure out that intercept. We're trying to figure out what 5 times 35 is. So if we evaluate that, we would get that to be equal to 170 plus our intercept is going to be all equal to 175. 175. Let's fix that before we keep rolling. So that's 175 plus our intercepts. So now we got to subtract 175 from both sides to find our intercept. Minus 175 minus 175. So we should get -7 is equal to b. So now we're not quite done yet. We know our slope. We know our intercepts. Now we got to plug them both in so we can find what our equation is for line number 1. So our final answer would be for this one, y equals 5x minus 7. And then we are good to go for that one. So next, Line 2. We got 3 more to go here, folks. So line 2, we're going to just keep rolling down the screen here. And we got to find the exact same information. We got to find those 2 points. We got to find our slope. We got to find our intercept. And we can find the equation of that line. So our points here, we have number 1, number 2. Number 1 is going to be 35, 168. Again, those 2 lines share that point, number 1 and number 2. Let's see here, then our second point is 79, 190. So now, let's plug that into our point slope formula. Hopefully we can do that one by now. So again, y2 minus y1 over x2 minus x1. So plug in the corresponding values here. We would get 190 minus 168 all over 79 minus 35, which is equal to, once we evaluate that, we should get 22 over 44. If we reduce that fraction, that goes down to 1/2. Should be 1/2. So that is our slope. That is that m value. That's our m value, that slope right here. There we go, that's what we want. So now we want to figure out what our intercept is here. So when we write our equation for this line, again, we'll try to keep all this stuff together. Oops. So let's try to keep that. Perfect. So y now is equal to mx plus b. Let's plug in what we know. Again, we have 2 points. Let's pick one. We know our slope is 1/2. So let's say y is 168. If we use this point is equal to, now we can do 1/2 times 35, which is our x, plus our b value. So we have 168 is equal to 17.5 plus b. So when we subtract 17.5 from both sides, minus 17.5 from both sides, we would be left with 150.5, which is equal to our intercept. And now we can plug both of these values in to our equation for our line, which is, again, right there. So we know that y is equal to our slope 1/2 times x plus 150.5 for line number 2. Again, for line number 3, same exact process. Same exact process. So number 3, I'm going to let you guys do on your own. It's good practice. I will give you the final answer, though. With those 2 points, which is number 1 and number 2, the point number 1 would be 190, and then we would have point number 2 as 123, 168. So when we get our final answer for line number 3, we should get that line to be y equals minus 1/2 x plus 229.5. So hopefully we can work through those same process of steps and then get to that line at the very end of it. And then lastly, line number 4. Line number 4. That one's a little different here. So let's do this one before we touch on domain and range and wrap up today. So line number 4. Again, our 2 points here, we have we have 35, comma 168, and then we've got 123, comma 168. So if we try to figure out our slope, we got y2, we got y1, we got x2, we got x1. So we have 168 minus 168 all over 123 minus 35. So 168 minus 168, hopefully we all know that's a big old goose egg, big 0 up on top. On the bottom we've got, let's see here, I believe that's going to be 88, what we're left with. So 0 divided by 88, 0 divided by anything is always going to be 0. And that is our slope. So if we have a slope of 0, hopefully, if we have our toolkits filled out, we know that our slope of 0 always tells us we have a horizontal line. And our equation for our horizontal line is y equals whatever our y value is. So in this case, our y value is 168. 168. So if we think about plugging our slope in, it'd be 0 times x plus 168. Again, 0 times anything is always 0, so our equation for a horizontal line is y equals 168. All right, so last thing I want to touch on before I wrap up. Again, I know this video is starting to get a little bit long, but let's touch on domain and range. Again, domain is all the possible x values for a line or a function, and the range is all the possible y values for a function. So let's take a look at line number 1. So line number 1, again, on our picture is right here. We are starting at 35, 168, and going to 57, 278 here. So our range of x values, our x's again go left and right, y's go up and down. So if we use that to figure out what a domain and range is, our range going left to right, we start at 35 and we go to the right until we get to 57. So if we want to write our domain for line number 1, I'm going to put that up here in red. I'm going to make some space first though. So our domain, our farthest left value for line number 1 is 35. And because we know that's a solid dot there, it's not an open dot, it's a solid dot, we have to include 35 in our domain. So it's going to be less than or equal to x, which means x can be greater than 35 or equivalent or equal to it. From there, we know our upper limit is 57, and again, it's the same thing here, where x can go up to 57, and it is included there by that solid dot. So x can be less than or greater or equal to 57. So that would be our inequality that would represent the range here, or domain, domain. So our range next is all the possible y values. So our lowest value for y is 168. Our biggest value for y is 278. So from there, we can just basically do the same exact thing that we did for our domain, but again, our variable is y. And again, with those solid dots, we have to use the same inequality signs, greater than or equal to or less than equal to. So again, our lower limit goes on the left, that's 168. And our upper bound here, the highest y value that we have is 278. And this would be domain and range for line number 1. All right, and again, I would recommend trying to find the domain and range for lines 2, 3, and 4 as well. If you get a chance, I'll put those in the filled in notes so you can check your work against that. But otherwise, once we move on here, the homework over the weekend here is 232, again, problems 290 through 294. So again, before you guys pack away and do wrap up for the weekend, make sure you get your toolkits filled out. Make sure you get your homework done. If you are missing that quiz from last week, please make sure you do so. Otherwise, I hope you guys have a fantastic weekend, and we'll see, I believe it is Group B in person next week, and we'll see you all otherwise live. So have a great weekend, everybody. We'll see you all next week.